Yes, today we will discuss the gravitational in the early universe. Before that, I will talk about today's topics in the very brief overview rather than the full derivation of the calculation. The gravitational waves are given by the linear perturbation of the matrix in the general relative theory. Under this, also the perturbations satisfy the twice loss and the transverse condition by the gauge choice. So there are only two equilibriums that remain, x and plus mode. And one can calculate energy density of the gravitational wave from the thrust energy tensor as all derivatives of the linear perturbing matrix, and the 0, components of the T minus is given by the energy density. And the density parameters as a ratio between the gravitational energy density and the critical energy density of the universe is given by the following form. And for each F mode, we can plot the density parameters over the frequency. So this is a plot of the omega CW with the multiplications of the Hubble parameters scales over the frequency of the gravitational wave as a unit of the hertz. In the upper visions, I exclude this out from the effective N by the observations of the Planck satellite, and this is these curves represent the detector sensitivity, like as LIGO and LISA. And for the specific gravitational waves, show that the following behaviors: convex curve, and the peaks of the this curve represent the mass scale or energy scales of the gravitational wave source or phase transition temperature. This corresponds to the scale of the energy. And the height of these curves represents as energy released during the gravitational wave generation. First of all, we will talk about impulsion of gravitational wave. In the impulsions, we can perturb the matrix, and there is a tensor mode which corresponds to the gravitational wave. The equational motions are given by the following form. The second term corresponds to the expansion effect, and the third terms are K mode. On the right hand side, there's a new term because there's an addition associated in the impulsion of FOPT. And in the scale invariant case, the plot of the gravitational wave energy density is given like that. There are two moments, which is the behaviors changes. The first one is the radiating temperatures, and the second one is the radiational matrix equality. So during the radiating before the radiating temperatures, the steps of the curves drop or borrow. And between the ratings and the matter radiation equality, the curve show that the flat behavior. And after that, the matter dominance era, the gravitational wave show that F minus 2 proportionality. Because the gravitational wave energy density follows 8 to the minus 4, but the critical energy density changes from the radiation dominant to the matter dominant. After the impulsion, there are several sources. So right hand side now get the energy tensor contribution. The possible sources several things in the extreme universe. The first one is color indices gravitational wave, which comes from the curvature perturbation. These color curvature perturbations coupled to the gravitational wave metric, and this gives a similar plot. Another possible source is a burst of the phase transition, unlike the crossover of the second order. There are two simultaneously existing vacuums, so that the state can transit from the Bose vacuum or metastable state to the Tiro vacuum. So that there will be the Tiro vacuums of bubbles that exist simultaneously in the one moment, and that this bubble will be expanded and collide each other, and the collisions of this Tiro vacuum bubble makes the gravitational wave. So that already I mentioned the peaks positions correspond to the temperatures of the phase transitions, and the heat is energy released during the phase transition. There are several possible bursts of the phase transitions in the universe. For example, the electroweak baryogenesis, which requires burst of the phase transitions to ensure that the RW equilibrium condition for the Sakharov, and usually this impose a Twix sublime model to make the burst order, and also the composite Higgs model can also make such a FOPT. The other possible source is a topological defect, like as a domain wall or cosmic string, depending on the symmetry making. For example, the cosmic string case, this occurs the U1 symmetry breaking already. We discussed it in the many previous video. And the vacuum configurations of cosmic strings is a non-zero, and there will be the zero line because of the continuous build, and the string tensions are given by the proportional to the pi v scale as a v is the Bev scale. And the string collisions or the scaling behaviors and the string network yield the gravitational wave with the similar form. So today we discussed the gravitational waves in the early universe briefly rather than the quantitative calculation. We focus on the possible sources and the qualitative behavior of the energy density over the its frequency.